Hello, another AQA A-level physics multi-choice question. If you want to try to answer the question now, please pause the video. If you got the answer D, well done. If you want to hear my explanation, keep watching. The diagram shows a small rectangular coil falling between two magnetic poles, north and south there. The coil is shown at 4 instants as it passes through the magnetic field. At which instant will the induced EMF be a maximum? Well, Faraday's law tells us that the induced EMF is equal to the number of turns on a coil, in this case it's just one turn, multiplied by the rate of change of flux. So how quickly the flux changes. So as long as we've got a changing flux, we're going to induce an EMF. At point A, there's no flux going through the coil, and an instant of a second later, there's still no flux going through the coil. So there's no change in the flux, so it can't be A. At point C, there's the maximum flux going through the coil. And even a fraction of a second later, there'll still be that maximum flux fully contained within the coil. So again, no change in flux, no EMF induced. Both B and D show a changing flux. As B is dropping, the flux is increasing within the coil, and in D, as it drops, the flux is decreasing in the coil. Now, the reason the answer is D is because we're looking for the maximum EMF. And very simply, that coil will be moving faster in position D than in position B because it's accelerating down towards the Earth. So the answer is going to be D because the coil's moving faster, therefore the rate of change of flux is greater than in B when it's moving slower. Answer D. I hope this was useful. I hope you'll subscribe. I hope you'll watch more in the series. Thank you.